Okay, now we're going to do the third video, which will be the formalities or the mathematical formal way to do the test for the difference between two proportions. So once again, let me share my screen out to you here. Here we are. This is the Google sheet that we built before. Remember, we were working with the baby smoke data. So this is mothers and fathers along with babies and a whole bunch of other information about the babies in a North Carolina hospital. Okay. In the slides, we had built the proportions we were interested in, and we had decided that for the difference between two proportions, it was going to be most interesting to say, let's look at, is the difference statistically different than zero? Because the null hypothesis is that the two groups, smokers and non-smokers, in the case we're going to be talking about here, are the same. And if we assume the groups are the same, then the proportion of low-weight babies in each of those groups is the same. And when you take the difference between those two, you get zero. Now, we already looked at a randomized simulation. Now let's look at the formalities of the actual hypothesis test. So we need both sample sizes and both counts. We already have those in our Google Sheet. We need to calculate proportions from the sample sizes and counts. We have that from our Google Sheet. Then we need to calculate this pooled proportion. Now in the previous video, I talked about what pooling meant. The idea is we're assuming that we've got two groups that under the naive assumption, these groups are the same. That's the null hypothesis. So I group them together. I throw the groups together and calculate this thing called a pooled proportion. In the previous video, you saw me actually just take all of those and put them at the very top of the icons. Well, let's go do that now. I'm going to come over here and I'm going to build my formal hypothesis test. And the very first thing I need is my pooled proportion. The pooled proportion, again, imagines that we have both groups thrown together. So that would mean I get 92 low-weight babies plus 18 low-weight babies, all in parentheses, out of parentheses, 873 mothers plus 126 mothers. And notice I didn't say which groups those mothers were coming from. It's because we're assuming those two groups are actually the same. Under that assumption, we would see about 11% of mothers to have low-weight babies. So that's just assuming that there is no difference between the two groups. Hey, 11%. Okay, so let's go back to the slideshow. We have our pooled proportion. That is given by this formula. So x1 plus x2 is however many I had from the first group plus however many I had from the second group. That's low-weight babies, out of sample size from the first group and sample size from the second group. Okay, we just calculated that. Then we need a measure of how spread out the standard or the sampling distribution is. That's called the pooled standard error. Now I'm going to come back to my randomized simulation here. This, again, is a mound-shaped, bell-shaped curve like we would expect, and it looks like a normal distribution because it is. There's some deep statistical theory that tells you this is a normal distribution. So I need a standard deviation on this normal distribution. And what gives it to me, without having to do randomized simulation anymore, is this kind of daunting looking formula. So we're just going to put this formula into action, and it tells us how spread out that normal distribution is supposed to be. I'm going to try and do this so I've got both of these on either side here. Okay, so there's one. This is going to be a little bit messy here. Now let's see if I can get these somewhat side by side. Okay, I think that's probably going to be good enough. So my pooled standard error. My pooled standard error is, now I'm following this formula over here on the left. It is a square root of my pooled proportion times parentheses 1 minus my pooled proportion, end that parenthesis, times, open a parenthesis. Now, it's some people like to put more parentheses than needed. You only need the ones that are listed here, plus the ones to start and end the square root, nothing more. So parenthesis, 1 divided by sample size from the first category, plus 1 divided by sample size from the second category. Close that parenthesis, that's this one right here, and then close the square root. Okay, now I'm going to click on that guy again so you can look at it. Put me on pause if you need me to, or if you need to. You should be getting something about 0.03. Now, if we look at our simulation, 0.03 is right over here. And if I imagine drawing a curve around this thing, there's a lot of random variability in these plots, so it's a little hard to see, but I would imagine the inflection point in the curve is right around here. You know, from the top coming down, the inflection points may be right in there, so 0.03 seems pretty reasonable. Okay, now I can get my z-score, which is known as my test statistic, right? And that is my difference minus the null hypothesis, which was a 0, divided by my standard error. So I am 1.25 standard deviations below the mean here. And my p-value, well, this is a normal distribution, and I'm reading left on the normal distribution. So that is norm.dist of my difference, comma, the mean, which is the center of my sampling distribution, that's 0, comma, the standard deviation, that's the spread of my sampling distribution, that's my pooled standard error, comma, 1, because on the normal distribution we are accumulating area. And hey, look at that, it's close to about 11%. Now, the randomized simulations will not be as close as what we saw for the single variable. That's okay. We're still in the same ballpark, and we still get exactly the same conclusion that we had before. This conclusion, this is not less than 5%, so we do not appear to have evidence that the two groups, non-smokers versus smokers, are different in terms of whether or not the mother will have a low weight baby. Okay, that's all of the mechanics for a 2-proportion hypothesis test. Now we're going to go through another one down below, and you're going to actually work through some of these mechanics again.